I want the full value that you're getting from this. And if everyone demands that, it's just like the multi-marginalization problem, the whole thing falls apart. Okay. So, I hope I persuaded you that this type of problem shows up in a lot of contexts. But the question is how can we try to solve it? So I'm going to try to argue that you're almost always going to need some sort of coercion to solve these types of problems. But first, let's consider what are potential private solutions. So one potential private solution is just that people are altruistic, right? So people often do public-spirited things like giving to charity, voting, which usually there's like almost no chance that they're going to have an impact on who wins the election, and yet they still go and vote. This is sometimes called the paradox of voting, so that's sort of altruistic. Or volunteering for military service, right? And people choose to do these things even though they're not classic self-interest. In problem 3, we sort of discussed how this could be motivated by something which, while not classic self-interest, is sort of self-interested. So, for example, people might do it for prestige value. They want to look good for other people. It might just make them feel good about themselves that they do this, right? Or they could be trying to show other people that they're a good person. And that's a little bit related to the prestige. So for example, people might give a bunch of money to charity because they think that a potential mate that they might meet will think if they're generous to charity, then they'll also probably be a generous person to them. Or they might think that, for example, I don't know if anyone here is pre-med, but a lot of pre-med people go and work as in a hospital, but mostly because that helps them get to medical school, because the medical school thinks that they're a good person if they're willing to go and do that volunteering, right? So there's no question that altruism and these types of motivations can help to solve some of these problems. That was the whole point of your problem set, one of your questions on problem set 3. But almost all these things require the slow development of culture, and that usually takes 50 or 100 or maybe even 1,000 years. So the Soviet Union tried to solve all of the problems of social organization by just inspiring a spirit of altruism in people, and that didn't work terribly well. In many situations, like the land assembly thing, if we had hundreds and hundreds of years, yeah, we might be able to develop a spirit in people that it will be really respected if you make the sacrifice to give up your land to help build the bridge. But that's probably not likely to work quickly enough for it to really solve the problem. So, if goods or bads are local, another private solution might be for people to move. So, for example, people can move to the place that supplies the good or the bad well. This is called TBlue Competition. And the idea is that local areas compete to attract people and to provide the best public services, like street cleaning, schools, police, fire, etc. But this crucially depends on mobility. That is, people need to be able to cheaply move to the best area, and the value of the good provided needs to not depend on the location. So, for example, if California did a terrible job of providing outdoor places to swim, it wouldn't be very effective for Minnesota to provide that really well, because it's frozen half the year in Minnesota, right? And so the whole value depends on being in the warm climate, right? But once you can move easily, that basically makes things excludable, right? Because you can not allow someone to move to the area unless they're willing to pay for it. It also makes things rival, effectively, because there's only so many people that can live in any given place, right? So in some sense, these local public goods are not real public goods in the sense of the things we were describing before. So the most famous solution to the public goods problem was come up with by these two Swedish guys, Lindahl and Vicselling. And what they proposed is easiest to describe in the case where we're just making a binary decision. So we're just deciding, should we build some project like a road or a bridge or whatever, or not, rather than how much of something we should do. And everything that we're going to do from now on, I'm going to do in terms of this binary project, but it all applies to a broader issue of how much we can do as well. So let's focus on this binary case. So imagine every citizen gets some value VI from if the project is built, but the cost of undertaking the project is capital C. One thing we could do is figure out, imagine we knew every person's value VI. We could compute what their share of the total value is, SI, which is the ratio of their value to the total value that everyone has, capital V. Now, if the project is efficient, that is, if capital V is greater than capital C, then it's also the case that if every person were forced to pay their share of the value in the cost, they would all want to build the project. Why is that? Well, if V is greater than C, then VI is going to be greater than VI over V times C, right? Because you can just cancel the VI's, and this is the same as 1 being greater than C over V, which is exactly what we want. So here's what we could do. We could say, look, everybody is being assigned their share, and they have to pay that share of the cost. And then everyone could choose to either agree to make their contribution, which is their share of the cost, or not to. If everybody pays the share, we build the project. If anybody fails to pay the share, if even one person disagrees, then we don't build the project. Right? This is called Vicselling Unanimity. And notice that this will work perfectly. Everyone will agree if and only if the project is efficient. Yeah, Matt.
But how could this ever actually work?
Wait. That's exactly the punchline. So don't steal my thunder. So if everyone is pivotal in the decision, everything is fine. Everybody has the right to veto, and therefore everyone is going to want to make the contribution if we know exactly the right share that they have, right? But would this really work in practice, is Matt's question. Good question. Okay. So probably not. And Lucy, could you tell us why this might not actually work in practice? Why was Matt so pissed off a minute ago?
Because you need to know everyone's actual, their value, and that's hard to obtain and measure.
Yeah, exactly. Well, so one problem, which is the less severe problem, but is also a problem, is that this system might not be very credible, right? Imagine that like 99 out of 100 people agree, and they're all really enthusiastic. And then there's one person who says no. Well, it's going to be really tempting at that point to say, okay, let's just raise that person's contribution from the rest of the 99 people, right? But if you do that, everyone's going to anticipate that, right? And then everyone's going to say, oh, I'm not contributing, right? But more importantly, you don't know people's values, right? And everybody has to agree, right? So if you misestimate anyone's value by a little bit, then it's going to get really dangerous, right? Because even though, it may be very, very low probability that that you get it wrong enough that any person disagrees, with a ton of people, the chance that one person says no is going to get really, really high, right? And that's why it's really hard to imagine using this system, because one unexpectedly stubborn person can ruin it for everybody else, right? And we can study this formally by crunching the numbers. So let's imagine that everyone has some value VI, and everyone has equal shares, 1 over n. And that the distribution of people's values is, because we don't know it exactly, it's drawn from some distribution f of VI, independently and identically across people. Okay. So then the probability that any individual rejects contributing is going to be the probability that their value is less than this, which is f of c over n,
What is C here?
the cost of the project. So then the probability that any individual agrees is going to be 1 minus f of c over n. And the probability that everyone agrees is going to be 1 minus f of c over n to the n. So imagine, and this seems pretty implausible, that we know people's values so precisely that we can make sure that only one person in every 1,000 would not want to agree to the project, right? That seems like really ambitious. But then, once we have 1,000 people, which is not a very big society, right? We already have only a 35% chance of success. And once we get to the size of a small town, like 10,000, we are down to 1 in 20,000 being the chance of success. Now, in principle, if different people had different distributions, we could adjust the shares that they're given using like some elasticity thing. But still, we're always going to end up in this situation where there's going to be a very, very high chance of failure. So this is the example I gave. As a function of the number of people, what happens to the probability of success if the chance of any person saying no is 1 in 1,000? So, yeah, it's reasonably high when we've got, small number of people, but then it just like very quickly dies off as we get up to, even 3,000 or 4,000 people. Okay, so this is not just true of this simple system that I described, where we just make every person, a take it or leave it offer, and everyone has to, either consent to their share or not agree. But in fact, it's true of any system. So imagine that rather than just saying to everyone, here's how much you have to contribute or don't, we ask people to say, okay, how much do you want to contribute? Well, as soon as we do that, then we're back to the collective action problem, because everyone's going to try to contribute less. On the other hand, if we don't let people say how much they want to contribute, and we just say, look, contribute or don't, then we're exactly in this situation. So we're basically damned if we do, damned if we don't ask people for what their values are. And this is the basis of a very fundamental theorem, which extends the Bergstrom corollary that we said. This is called the Maillot and Postlewaite system. And it says, if everyone has to consent in order for the public project to go through, and there are no external funds available, then the probability that the project is undertaken always goes to 0 as the number of people gets large. In other words, no private, and by private I mean voluntary and self-financing system can ever work. That is, we always run into the collective action problem. Public projects, either good or bad, will always require some coercion. And we did this in the binary case, but in the case where it's a quantity, it's basically the same conclusion. Any system will always lead to almost nothing being contributed as the number of people get large. Okay, so coercion can basically operate in 2 different ways, which are meant to address these 2 conditions, that it's to be voluntary and self-financing. And so Raj, how can you imagine coercion dealing with each of those 2 problems?
If you have like a government that's taxing from these projects, then you have the financing issue of these voluntary issues.
Yeah, so it doesn't have to be self-financing if the government can raise taxes from outside. And how could just, if it's not voluntary, how could we solve this problem?
If this situation is like isn't.
So if we don't have to, if it doesn't have to be voluntary, if the government can coerce people, how might the government solve this problem?
Is that tax coercive?
Well, yeah, so I mean, if you just tax the people in the community, so in some sense, these are exactly the same solutions, right? We can either tax people outside of the community, or we can tax people inside of the community. But both things we need to coercively tax people, right? Okay, so we can force the people in the community to consent to giving the money,